more important than what we're doing right now.
Actually.
And you're the one, your parent wasn't home? Okay. Scientific notation, guys, come on, you've all done this a million times, this is easy. You gotta get through this, so we can start talking about more fun stuff. Okay. So here we go, scientific notation. Rule for scientific notation, we talked about it last time. Number, it's gonna be a number times 10 to the something, right? And the number has to be between 1 and 10. In other words, it must have just one digit before the decimal point. So this one has a whole bunch of digits before the decimal point. So we're gonna move that decimal point 1, 2, 3, 4, 5, 6, 7 places. So 3.61 times 10 to the 7th. Everybody okay with that? You've done this so many times. Okay. Now, this is the other way around. This number is in scientific notation, and we're going to rewrite it in regular decimal notation or standard form. We'll call standard form. So obviously, you gotta move the decimal point. Which way am I gonna move this decimal point? To the right. To the right. And I've got a little shell here with no eggs, so I'm gonna stick it in there. So it's gonna be 5,940. This one is exactly the same thing, only since the exponent is negative, it means my number is real little. Negative exponent means a little number, so I'm gonna move that decimal this way. I have 2 shells this time, so 0.00594. All right, we good with that? Okay, so we're done with P1, that homework's gonna be due Wednesday. All right, here we go, hopefully P2 will be too. Let's see if we can get through it. All right, this little vocabulary. Who can name some of these things for me? What's this called? Origin. Now, I know, I don't want to get you too excited, but when we get to chapter 6, we're going to have a different coordinate system. We're going to have a circular coordinate system, and that point won't be called the origin anymore, it will be called the pole, like the North Pole, because we'll be in a spherical system. But in the rectangular system, this system is called the Cartesian coordinate plane. Rene Descartes, one of the great mathematician philosophers, Rene Descartes, so this is named for him. He was the first one, or credited with being the first one to draw mathematics. So when you graph like a parabola, that's a Cartesian thing. Okay, so anyhow, that's the origin. What do we call this? Y-axis. This one is called the x-axis. And these 4 sections are called quadrants. And the quadrants are numbered. Anybody know how they're numbered? Sam?
So 1 is the top right.
This is quadrant 1. We're going to use Roman numerals.
And then 2 is top left.
Yeah.
And 3 is bottom left. And 4 is.
They go in order and they go counterclockwise. So quadrant 1, 2, 3, and 4. Perfect. A scatter plot is simply the word that we use to describe plotting a bunch of points. So your job is to plot these points. Do it. This should be easy for you. You should be doing it. You should be able to do it. When you plot them, would you label them, please? Anytime we're graphing not on graph paper, we should label. How'd I do, okay? Sometimes the question will involve, which quadrant is this point in? Be careful, this point right here is not in a quadrant. If you had to describe the location of that point, you would say it's on the positive y-axis, right? Easy. Okay, absolute value. Tell me what you think of when I say those two words, absolute value. What pops into your head? Distance from 0 on the number line. Okay, how far are you from 0? Okay, because it's a distance then, it will always be positive, right? So let's talk about the definition of absolute value. The definition of absolute value. Now intuitively you know what it is, but it has an actual formal definition. The absolute value of x is x if x is greater than or equal to 0. Does that make sense to you? If x is a positive number or 0, when you take the absolute value of it, you just get the same thing. Right? What happens though if x is negative?
Negative x?
Exactly. And actually we don't usually say negative x, although it's fine if you do. We say the opposite of x. Because absolute value will never be negative. But if you take the absolute value of a negative, you get its opposite, right? So if you took the absolute value of negative 4, you would get the opposite of negative 4, which is positive 4. Don't let that freak you out. That's an opposite. You get the opposite thing. Okay. There are a few little properties of absolute value I wrote in there. It's always positive. The absolute value of a product is the product of the absolute value. Same thing with the quotient. And the absolute value of the opposite of A is the absolute value of A. That's easy. Okay? Now, we are going to do something a little bit different here in just a second. I need you to agree with me. Better yet, I need you to understand that if I want to talk about the distance between these 2 points on the number line, think about that for a second. If the letters confuse you, use numbers. If I want to talk about the distance between these 2 numbers on the number line, could I do 7 minus 4? Would that give me the distance?
No.
Could I do 4 minus 7? Yes, as long as I put it in absolute value. So on a number line, the distance between 2 points, subtract them in either order, it doesn't matter, as long as you take the absolute value. So the distance on a number line is the absolute value of the difference. The absolute value of the difference. You're thinking, well, yeah, that's not too hard, Miss Ford. Why do you make such a big deal about it for? Well, let's look at this next problem. I know that you know, or at least at one point you knew, how to solve this equation. Some of you will split it up into 2 equations and say, okay, so x minus 4 equals 5, or x minus 4 equals negative 5. Remember doing that? Okay, now that will always work. Well, it'll always work as long as you only have one variable in there. I want you to start thinking, if you would please, like a calculus student, because differential calculus is based on the derivative, and the derivative is a limit, and it is described in terms of absolute value. This way. On my number line, this is an absolute value of a difference. So I'm gonna put 4 right here, and I'm gonna put X right here. I don't know where X is, I'm just gonna put it right there. And this says that the distance between those two numbers is 5. The absolute value of a difference is the distance between two things on the number line. So this says the distance between something and 4 is 5. So what should this number be? If the distance here is 5, then what is this number? Well, this one would be 9, right? Because it could be that way. So that one would be 9. What would this one be? Negative 1. So the answers to this problem are -1 and 9. The distance between something and 4 is 5. So here's 4. 5 that way makes 9. 5 this way makes -1. Same thing, try this one. Now be real careful. Remember, the absolute value of a difference is a distance. The absolute value of a difference is a distance. What's wrong with that problem? It's a sum. Any idea how we get around that?
It's a negative.
It's a double negative. That's exactly right. That's exactly right. So this says the distance between something and -2, the distance between something and -2 is more than 6. So here's -2. If I go exactly 6 out this way, where would I be? 4. And if I go exactly 6 back this way, where would I be? -8. Now, these 2 points, the circled points, are exactly 6 away. I want to be more than 6 away. So my answer is going to be all of this or all of this. These are the points that are more than 6 away from -2. So X is less than -8 or X is greater than 4. Since we're calculus students, or almost, we're getting ready to be calculus students, we're gonna write that as intervals. So what would this be in interval notation? Negative infinity, comma, -8, perfect. And I'll use parentheses for both of those, right? Union, that's our symbol for or, that's the union symbol. Or infinity. You guys are outstanding. You're wonderful. Absolutely fantastic. Okay. Ms. Ford, I don't know what language you're speaking. I just want to do it my old way. That's fine. You can do it your old way. It will work. I'm not going to do it your old way, but you can do it your old way. I just want you to be open to start thinking along these lines, because it's going to help you down the road. Okay? All right, next. Write as an absolute value. The distance between X and 6 is 7. We're going to write that like this, something like this, with an absolute value in it. The distance between X and 6. Stop right there. Distance is the absolute value of a difference, isn't it? Write that down if you haven't already. Distance is the absolute value of a difference. So when they talk about the distance on a number line, that's a subtraction. So the distance between x and 6 is 7. The distance between -3 and x is less than 5. The distance between -3 and x is less than 5. Now, if you did this, that would be perfectly okay. Normally, we have our x first, but if you wrote this literally from what the problem said, that would be okay too. These are the same thing. Because you can take a negative out of here, and the absolute value of negative. It's possible. All right, last one. The distance between x and a, there it is, there's the distance between x and a, is at least d. Is at least d. What do you think about that? Greater than or equal to d. Perfect. Okay? All right, 6, midpoint on a number line. What do we mean? How do we find the midpoint on a number line? So if this is point C and this is point D, here's the midpoint, what would be that point right there? Yep, Sydney?
Okay, never mind. I thought I knew. I was gonna say the distance, but if you like divide that by 2, but no.
Okay, so what you're saying is to do something like D minus C, which is the distance between them, and divide that by 2?
Yeah.
Okay, now, that didn't give me the coordinate of the midpoint, that told me this distance right here?
Yeah, and then take that coordinate once you apply that.
Okay, you can do that, it's way easier than that though, okay? It's way, way, way easier than that. Let's look at it with numbers. If I put a 4 here and a 10 here, what's the midpoint? 7? Because midpoint is average, guys. If you take 2 quizzes, and I wanna know what your middle score is, don't I just average them? You have an 8 and a 10, don't I average them? How do we find the middle of anything? We average it. We average, average, average. So, how do you average a C and a D? You add them and divide by 2. That's how you're gonna find midpoint, not just on a number line, but anywhere. Midpoints are always just averages. We're gonna add them and divide by 2. So, what's the midpoint of 6 and -9? -3/2, or -1.5, or -1.5. There's nothing wrong with improper fractions. So feel free to leave it -3/2. But if you feel better another way, do it another way. -3/2 is your midpoint. How about -2/3 and 7? All right, now we're gonna have to practice our arithmetic a little bit. We need to average these 2 numbers. We need to average these 2 numbers. So we'll add them. I got 19/3 when I added them. Okay, then what do I have to do? Divide by 2, which in fraction land, it might be easier just to multiply by 1/2. So your midpoint will be 19/6. most of our work is not gonna be done on a number line. Most of our work is gonna be done in the coordinate plane. So we need to have the same conversation about points in the coordinate plane. How do we find distance and how do we find midpoint? So this is 8A, problem 8A, these are the points. We need to find the distance, and notation for the distance is AB. Please don't put a line above it, below it, around it, it's just AB. That means the distance from A to B. And then where to find the midpoint of AB. Now, in order to do that, we got a couple of, well, we got one formula for sure. Anybody remember your distance formula in the coordinate plane? It's a big radical. Anybody remember how that works, Tess?
Like if you have two coordinates.
Uh-huh, yep, like two ordered pairs, like this right here.
X squared plus y minus y.
Exactly. And she said it exactly how we learn it. When I write it down, I have to differentiate between the x's. So I'll say something like this, but don't let that confuse you. What you said is exactly right. X minus x, y minus y. But I have to go in there when I write it. So, Tess, for this problem, our distance will be -1 minus 2. By the way, does it matter which order I subtract those? Nope, because you're going to square it. So if you do -1 minus 2, you get -3, but -3 squared is 9. If you do 2 minus -1, you get +3 squared is 9. So it's not going to matter. Subtract however you want. Plus 4 minus 3. So I got 10, square root of 10. What about you? Does that look about right? Keep an eye on my arithmetic. All right, now we want the midpoint of that segment. What did I tell you a minute ago? I looked right at you and I said midpoint is? Starts with an A, average. Midpoint is average. So if I want the midpoint, I am going to simply find the average of -1 and 2, my x's. What is the average of -1 and 2? Well, add them and divide by 2. So we are average, I heard somebody say 1/2. Perfect. What is the average of my y's? 7/2. Now, if you're one of those people that absolutely has to have something to memorize, it's the average, right? It's the average. We are never, ever, no one in your life, probably from now on, is going to ask you to write a formula. You have to know the formulas and know how to use them. Okay? So know how to find a midpoint, know how to find a distance. Those are important skills. Those are valuable skills. All right, do 8B on your own. We'll get somebody up here maybe to do it for us on the board. 8B. Same thing, you're finding distance and midpoint. So if you think you can find distance, come up and do it. If you think you can do midpoint, come up and do it. Right big enough for the people in the back to see.
just 2.25.
Oh, where are my volunteers? Here comes one, thank you.
What?
Are you doing midpoint or December
Oh, yeah, 6.25.
Remember to be considered simplified. Something can be written as an improper fraction, as a mixed number, or a decimal. Please do not mix those. So there should not be a decimal inside a fraction, and there should not be a fraction inside a decimal. Okay, how many, thank you guys, thank you for coming up and doing that, much appreciated. How many of you whipped out a calculator? Okay, so what would we do if I took the calculator away, which I will? We'll have some calculator, some no calculator. What would you do if you didn't have a calculator? First of all, I think the arithmetic here looks fine. -7 minus -5.5, so she added 0 minus, that arithmetic just looks great. But what if we took away the calculator? Who has an idea? Marin?
I'd multiply, I mean, if you didn't want to deal with decimals, you can multiply everything by 10.
Oh, you mean in the original problem? And change that into a 55 and a 5?
True, it never.
Will that change my answer? Is 55 comma 5 gonna have the same distance from this point as this one does? No, so we're not gonna do that. Let's go back, let's think about what she did, it was fine. But if I'm not using decimals, or even if I am using decimals, this would be -1.5. And this is 0.5. Now what if I change that into a fraction? So what would this be as a fraction? 3/2 squared, so what is that? 9/4. Fractions are your friends, they're easy. They're easier to deal with. So 9/4, okay, this is 1/2, right? Squared would be 1/4. So what we have here is the square root of 10/4. How do we take the square root of a fraction? Top and bottom. So it's gonna be the square root of 10 over 2. And you know the rule, you can't have a radical in the bottom. We don't. This is it. This is your simplified answer, right there. Did you follow that? Let's not be too quick to whip out the calculator. All right, can we do the same thing with him? All right, so I'm gonna go ahead and have to add these two numbers together. So this is -14/2, and this is -11/2. Would you agree with me? So when I add them, I get -25/2. Which is -6.25. And then I'm gonna add 0 and -1/2, which is -1/2, but half of the, oh, what shoot, I didn't take half. Sorry about that. This is -25/2, and I have to take half of that. This is -1/2, and I have to take half of it, so it's -1/4. So there it is without any mechanical assistance. Couple more and then we'll be done for the day. Flies when we have these little short periods. Okay, here we go. Well, I think it flies. I'm not sure you guys do. All right, so here's the situation. I'm in problem 9. It says I got M is the midpoint of AB. M is -3, 6. And B is 2, 4. And my job is to find it. All right, what do you think?
Find the distance between M and B and double it.
Now, let's think about that. If I find the distance between M and B, chances are it's gonna be a radical, right? I mean, like root 10 or root 53 or something. Is that really gonna help me? I know whatever that distance is, it will be the same over here, but is that gonna actually help me find the coordinates? Not directly, we could probably finagle our way through that, but it won't give it to me directly. What do you think, Tess?
2 plus x over 2.
Oh, she says we know how to find midpoint. We know this has to be the average of these two. So whatever x and 2 are divided by 2 has to give me -3. Does that make sense to you? That this number and this number averaged have to be -3. So I got -8. Is that what you got? And then Tess, we'll do the same thing with y's. So y plus 4 divided by 2 has to be 6. Shoot, I got 8 for that one, did you? Positive 8? Now, does that make sense to you? Sure it does. I want to show you something else though. Remember, I didn't know what this was, but I have these two. From -3 to 2, pretend you're walking. From -3 to 2 is how many steps? 5 in the positive direction. So if we went backwards, wouldn't we have to go 5 in the negative direction? So if we backed up 5 from -3, we'd be at -8. And then similarly, 6 to 4 is backing up 2. So we'd have to go forward 2 this way, and that puts us at 8. So that way we can use our distance idea, but we're not actually finding the actual distance. We're doing it one coordinate at a time. All right, one more, and then I will shut up, I promise. Find the area and perimeter of this triangle. So we have 0, -1. We have 4, 4. Oh, that's us. And we have -5. Here's my triangle. And I'm gonna find the area and the perimeter. What's perimeter mean? Distance around all the sides added up. I think that's pretty easy, right? So let's divide and conquer. So you first row over there, would you find CH? You guys in the middle, would you find HS? And you guys over here, would you find CS? We're all just doing the distance formula, right?
Yeah.
So So each row is doing one side, but you find each side the same way. So it should be okay. Yell it out when you get it. What'd you guys get?
Square root of 41.
Square root of 41 for CH, square root of 41, perfect, okay? HS, CS,
32, square root of 86.
square root of 82,
Yeah.
I got square root of 41 for HS.
square root of 41
I got
for
41.
HS.
Yeah, I got 3.
Okay, that's all right, just means our triangle is isosceles, that happens, especially when you pull problems out of the book and they're rigged, right? But there's something even more special about this triangle. So wait, first, perimeter. Perimeter would be the square root of 82 plus 2 root 41s. Would you be okay with that? Remember, you can't add those together. They're not like radicals, so we just gotta leave it like that. That would be our perimeter. This triangle you've already observed is isosceles, but there's something even more special about it. Marin?
We call it perfect square. Okay, I can't remember the word for it.
Okay. Do you remember what it means? What are you looking at here to use the?
Oh, the angles. Wait.
This is a right triangle. It's a right triangle because the Pythagorean theorem works. If you squared that and squared that, doesn't it add up to this squared? So a squared plus b squared equals c squared. So that's a right triangle, and the area will be 1/2 base times height. So the area of the triangle is 41 over 2. Now, if that hadn't happened, we aren't ready to do that problem yet. But since it's a right triangle, base and height, 1/2 base times height. Okay, guys, good job. Good work. I will see you sometime tomorrow or the next day. And we will forge ahead even more. Have a great day.
It's called.